All right, let's look at some examples again of substitution here. Our function within the function on this one is right here, so that would be our selection for u. Again, we're going to find derivatives now, so du on this side, the other side. This hasn't came up yet. This one is going to be a derivative that involves chain rule, so chain rules could come up here. Derivative would be e to the 3x, derivative the inside one is 3. The derivative of the minus 5 is 0. That's a constant, but we have our dx on here. Okay, so now when we substitute here, we get this is going to turn into the 4th root of u. Now the rest of this doesn't substitute exactly like it had in some of the previous problems. So what you want to do now is try to look at, well, what about if we just did a substitution then for like dx here? So if we made, if we divided here by 3, or another way of thinking of that is multiplying by 1/3. That would get rid of that 3 that we had there, and then we can kind of cancel out the remaining stuff. So now what we have is e to the 3x dx being equal to 1/3 du. So when we substitute now, this and that will turn into our 1/3 du. And then we still didn't do anything with this 12, so that 12 would come down that we had right there. So now to integrate this, let's simplify our constant and pull it out. So 12 times 1/3 or 1/3 of 12 is 4. We'll pull that outside of our integral. This radical is going to be easier to integrate if we think of it as it to the 1/4 power. And now we've finally got an easy one to do here. So add 1 to our exponent would be 5/4. Reciprocal would be 4/5. We still have that other 4, so we need to multiply that there, plus some constant. Final step now. Let's multiply those two constants together. Substitute back in for u. And then we have our plus c, and that would be the antiderivative of this one. Here's the trig one. Sometimes when you're doing it, your inside function may occur more than once. That's okay. When we do our substitution here for u, we just can put it in for both. So here u is going to be pi over x. Derivative then is just pi dx. Again, we don't have a pi there to cancel out. So in this one, let's move that to the other side by dividing. So it'd be like a 1 over pi du. So now when we substitute, this is going to turn into cosecant. This would be a u, just like this one's going to turn into a u. So cosecant of u, cotangent also of u. We have dx turning into 1 over pi du. So I'm going to turn this into du. We still have that that constant of 1 over pi here. In addition, we haven't done anything with that 2, so those 2 would be constants we could pull outside of our integral. So that would be 2 times 1 over pi or 2 over pi. All right, so that way, when you pull out those constants just off to the side, you don't have to worry about them until after the integration. So now to finish this one, if we look at what's left, what's the antiderivative of that? Well, we have a derivative sort of similar, derivative of cosecant is negative cosecant x cotangent of x. So that's very similar to the one we got here, except the integral we have in this problem isn't negative, which means the antiderivative of this one should end up being negative cosecant of u. Plus c, and then we got to make sure again we pull our 2 over pi constant with this. Okay, next, now let's substitute back in. I'm going to move that negative out in front here. And then we'd have cosecant. And now instead of u, we substitute back in. So pi x plus c. And there's our antiderivative. All right, why don't you pause the video here, see if you can do this one. All right, let's see what you had. Kind of some choices here. Do you put u equal to cosine or the sine to the fourth? Well, on this one, the more inside one there, the one that's inside the function is the sine x. So derivative would be cosine x. There's our cosine x. That's going to cancel out. So this all turns into du. The sine turns into the u. One thing to make sure when you are substituting here, don't forget that power of 4 there. And now do the antiderivative just using our power rule here. So 1/5 u to the 5th plus c. And then finally substitute back in. So you got 1/5 and we substitute for sine. And so there's our answer. Normally, you're probably going to see this written back in that other notation where you got the sine and they put the power there. And they may like throw it over this since you're multiplying. So just something to be aware of when you're doing those. Okay, next example. This one has a lot, some other constants in here. You can see an a and a b. If they throw one of these ones at you, you have to look at what's that constant of integration there, x. So x is a variable. A and b in this one, even though they're other variables, they're just constants. So you still have to treat them as that when you're finding derivatives. Where we have our function in the function is here. So that would be our choice for u. So now let's find our derivative, du on the left side. 4 and a are just constants here. So if you got stuff in front of it, x, when you take a derivative, it's just going to be those constants plus, now let's do our other one, bring down our 4. So 4, b is another constant that would get multiplied by 4. X, new power would be 3. Dx here, and should have that parentheses since both of them are times dx there. All right, so now we want to substitute in. Now, when we do this, I don't see anything that's going to directly cancel that. So let's do like we've done in previous problems. Let's divide by that. So we're going to end up with du here divided by all this. So making our substitutions now. We got this a plus bx cubed all over square root of u. And then our dx turns into this du over this stuff. All right, so now what we got to figure out is how can we get rid of these x's? Because we can't integrate when we got u and x in there. We need those x's gone. And right now, these two things do not cancel out the way they are written there. But it does look, if you look at this denominator, that there is something we can do to that to possibly get these to be the same. I see 4 on both of those. So let's pull out that 4, that greatest common factor there, and see what this one looks like when we do that. So if we pull out this 4, what's left is a plus bx cubed. Now that looks like the numerator we have over there. We can cancel those out, and that's very helpful now because we couldn't integrate until we got rid of that. So now let's finally get what this one looks like. This 4 can be pulled out. Now again, you got to be careful. Don't pull that out like this, or you're going to get it wrong. That 4 is in the denominator. If we pull it out, that'd be like a 1/4. And then the only thing left is our du and our u to the 1/2. I'm going to move that up into the numerator and make it u to the negative 1/2 to integrate here. So now if we find the antiderivative, it would be adding 1 to that is u to the positive half. Reciprocal of 1/2 is 2 times our 1/4 that we had there plus c. So putting our two constants together, 1/4 of 2 would be 1/2. And then substitute back in for u. and our substitution here had been the 4ax plus b x to the fourth, and then plus some constant. And the power on here is half. Most likely on the test, you're going to see that instead of written as a half, they'll turn that back into radical notation because we know power of a half is the same as square root. So you'll probably either see an answer like that, or since we got a 1/2 there, you might also possibly see it as just like all over 2 here. So that would be our solution. This one, integrate using substitution. Well, this one, it presents something interesting. We got this function of sine with this inside of it. So most likely this one, our substitution is going to be square root of x, and it is here. But how you treat this one kind of can be a little bit different sometimes. Again, this is going to be x to the 1/2. So when we find our derivative here, it'd be 1/2 x to the negative 1/2 dx. So when you're substituting here, our substitution is u. So we can put u in for both of these, is one way to do it. So then we'd have sine u over u. But then we have this other stuff here that we have to substitute in for dx. So let's see what that ends up equaling. I'm going to move that x to the 1/2 down to the denominator. And so if we times that to the other side, then the dx is going to equal 2x to the 1/2 du. So our substitution for dx over here becomes that stuff, 2x to the 1/2 du. Well, remember how we said though we're not going to be able to proceed though with that x there. So we need a way to eliminate that x. Well, a couple ways you can do this. On one, you can notice if we have x to the 1/2, another way to write that then is square root x. And that's helpful because remember, what was our substitution originally? U equals square root of x. So we could do a substitution here and make that, again, we could make that a u. And then now everything has a u and we could go on. Another way to do it would be to not necessarily make that substitution right away and leave that as a square root of x. And recall that we had a square root of x there before. And then just cancel those out would be a second way of doing it. Either way, whether you have u's there or square roots of x's, they should cancel out. So now you can pull that 2 constant out. This is just the integral of sine u du. Antiderivative of sine is going to be negative cosine u, because remember, derivative of cosine is negative sine. But this is a positive one, so we need a negative in there. Plus c. And so our final answer here, substituting back in, would be negative 2 cosine of square root of x plus c. So there's our solution.